Alright, and welcome back to our video lecture on signals and systems. So this is the example 2 under convolution using the tabular method. So if you miss the example 1, kindly check the playlist on signals and system, and then you'll find the link there so that you can also watch that. Alright, so now let's take a look at this example. Now we are given these two signals, we are asked to convolute them. Alright, so unlike the example 1 that we looked at earlier, which is which is this, you can see for this now we're giving the a mathematical expression of the signal. This is for x of n and this is for h of n, but in this example that we want to look at now, we are just giving more like the graphical representation. So right here is our h of n, and this is h of k, and this is x of k. So they can use anything, just take note, but one thing that is always constant is x and h. So this alphabet inside, it can be k, it can be n, it can be anything. Don't let it to confuse you. Exactly, it's still the same step we are going to use as long as tabular method is concerned. Exactly. So because the other one we use h of n and x of n, and now we are using h of k and x of k. No, don't let it confuse you. Like I said, x will be constant, h will be constant. Exactly. Even if it is different anyway, just understand the step. Alright, so now let's get started. So to start with, we're going to have our table. Exactly. So let me have our k. So if we have our k, so again for this our k, we are going to start from minus 2, because just like we did before, by the time we flip our h of k, because like I said, it's our h of k that we are going to flip to give us our h of minus k. We don't really need to touch x of k. So if we should flip this now, since we are having 2 here, which is that's the last thing here, is the highest value of k here with a particular signal here. Since we have 2, by the time we flip it, it becomes minus 2. Exactly. So since minus 2 would then be should I call it the highest or the lowest? So we are going to start from minus 2. So if we have minus 2, minus 1, 0. So let's just take it to 5 like the other example we looked at. 0, 1, 2, 3, 4, and then 5. Exactly. So then we bring in our x of k now. So our x of k, okay. So for our x of k, you can see at 0, we are having an amplitude of 3. So at 0, our amplitude is 3. So when it is 1, the amplitude is also 1. And then when it is 2, the amplitude is also 2. So that's 3, 1, 2. So that's what I was saying in the other example 1 that we looked at. That unlike in the example 1, which is this, so you can see we're having just 1, 1, 1. But this time around, we are having another example such that our x of k is having 3, 1, 2, a different number or a different amplitude. So now let's bring in our h of minus k. So which is our h of minus k. So this is our h of k. By the time we flip it, let me see if I can smuggle it some, or I can just draw it somewhere. So if you should flip this, we are going to have something that looks like this. So this will be 0, minus 1, minus 2, and this will be minus 3. Okay, so by the time we mirror it or we flip it, and then so it's going to look like this. We're going to be having something this, and then this. So this will be 1, this will be 2, and this will be 3. Are we good? All right, so now let's bring it here. So let me just use a different color. So we are going to be having h of minus k. All right, so for h of minus k, which is this. So for h of minus k, at 0, we are having 3. So when it is minus 1, we are having the amplitude to be 2. And then when it is minus 2, we are having the amplitude to be to be 1. So this is what it will look like. Alright, so now let's continue. So for h of minus k plus 1, so let me just write, we're going to be having h of minus k plus 2, h of minus k plus 3, h of minus k plus 4. So let's just stop here now and see if that's actually where we are going to stop or we are going to need. Remember in the other video too, I've talked about it, how to determine where you have to stop. Alright, so the next thing we want to do is you start to shift this h of minus k by 1, 2, like that. Alright, so if you should shift this now by 1, that means we shift h of minus k to plus 1, we're going to be having it as 1, 2, 3. Is that good? Are we good? So let's also shift this by 2. So that means we are going to be having 1, 2, 3. If you shift this now, we're going to be having 1, 1, 2, 3. If we should shift this now, we are going to be having 1, 2, 3. Alright, I hope we are still on the same line. Okay, so let me just draw some vertical lines because I think it's no longer straight, so that everything can be properly aligned. Okay, so let me just tidy this up. Alright, so I think it's looking more better like this. So let me go ahead and include alright, so let me include that of 5. Now what I want to do now is, once you've achieved it to this level, now start from h of minus k, which is this here. So let me just trace that out. So for that, we are going to be having, so this is it. So let's y of 0. So what we are going to do is, we are going to look at this. If there's any value that is on the same line with what we have here, let me circle it in red. So this that is circled in red. So we are going to look at it if there's anyone that is on the same line with it. Exactly. So right now, this 3 and this 3, they are on the same line. Exactly. So you can see for 2 and 1, there is nothing on the same line with this 3, 1, 2. So with that, we are going to be having our y of 0 to be equals to 3 times 3, which is equals to 9. I hope you get that. Alright, so now let's look at for h of minus k plus 1. So if we should trace that out, we are going to be having it as y of 1. So for this now, we can see that 2 and 3, they are on the same vertical line. Also, 3 and 1, they are on the same vertical line. So that is going to be written as 3 times 2 plus 3 times 1. And if you should look at it, 3 times 2 is 6, 3 times 1 is 3. So that will give us 9. I hope you got the concepts now. So let's go to the third one. So this is going to be y of 3. For y of 3, let's see. Okay, so you can say this and this, they are on the same vertical line. 1 and 3, they are on the same. 2 and then 3, they are on the same vertical line. So we are going to multiply each of them together. So that will be 3 times 1 plus 1 times 2 plus 2 times 3. So 3 times 1 is 3 plus 2 plus 6, and that should give us 3, 5, 11. So that's 11. So this is 11. Okay, so let's go to the next one. This is y of 4. So if you are to look at this now, the only thing that is on the same vertical line, 1 and 1, then 2 and 2 are on the same vertical line. Alright, so let's do justice to that. So we'll be having 1 times 1 plus 2 times 2. So, and that will give us 5. Yes, 5. So for this also, this will be y of 5. So the only thing that is on the same vertical line is 2 and 1. So since 2 and 1 are on the same vertical line, so that will be 2 times 1. And that will give us 2. Exactly. So that means we need to still add, okay, so let me just, so this is to this, this is to this, this is to this, so that we don't miss the lines. Alright, so let me add the h of minus k plus 5. So if you are to shift this also, it will start from here. So this will be 1, 2, 3. Are we good? So this is to this. So let me just put that arrow. So the reason why I'm adding this line is so that you can just get the horizontal arrangements, because the table is not properly aligned. So for this, it's going to be y of 6. So you can see at this point now, it is already out of 312. It is no longer within 312 again. So because there is nothing here, so we can just say that is a 0. Then you can just write it in brackets, no overlap. Exactly. All right. So basically, these are the values we need. 9, 9, 11, 5, 2. Then you can just add 0 just to let you know that, okay, at that point there is no overlap. So this is for y of 0, this is for y of 1, this is for y of 2, this is for y of 3. Okay, I think I've mixed something up here. 0, okay. Oh, there's a mistake somewhere in this. So this should be 2, 3, 4, and then 5. So let me quickly correct this. So this is y of 2, 3, 4, and then 5. Okay, so this will be 4, and then this is 5. So now with this, you can use it to plot a graph of what the convolution of h of k and x of k will look like. So let's just write it like this, that the convolution of h of k, of h of k and x of k. So this is the sign convolution. So let's just say it's equals to y of k. Exactly. So the drawing will just look, the graph will look like this. So where, okay, the maximum amplitude is 11. So let's just do something like this. So 2, 4, 6, 8, 10, 12. Exactly. So, and then, so this is 0, 1, 2, 3, 4, and then 5. Alright, so let's do this. So at 0 it is 9. So at 0 it is 9. So 9 should be somewhere here. So you can just trace it down. Exactly. So then at 1 it is also 9. So 9 is also somewhere here. Trace it down to 1. So at 2 it is 11. So 11 should be somewhere here. If I should trace it like this. So when it's y of 3, that's 5. So 5 should be somewhere here. And then for 4 is 2. So this is 2. Then for 5, it's 0. For 5 is 0. So basically that's the solution to that question for this example 2. I believe we didn't even spend too much time in this example 2, because All the explanation I've done it when we're in example, when we go through this example one. I did more explanation here. So I believe this example 2 is understandable. So if you have any question or any doubt, do make sure you leave it in the comment section. If you find value, please give it a thumbs up. And then again, if you are yet to subscribe, please click on that subscribe button. So just show some love, show some appreciation. Click on that subscribe button to subscribe. And then I'll see you all in the next one.